So here in this problem, we need to resolve the given rational fraction into partial fraction. Let us begin. Now, as we can observe here, there are three factors in the denominator. So the factors are, let me note them down, x cubed plus x plus 1. So this is the numerator part. In the denominator, we have the factors x squared plus 2. So this is one of the factor. And the other two factors are x squared plus 1. So this is repeating twice. Now, since we have two factors, contribution from x squared plus 1 and one factor of x squared plus 2, so this is going to have three partial fractions. So let us suppose that it can be resolved into three partial fractions as ax plus b. Now we have to take ax plus b divided by x squared plus 2. The reason behind this is x squared plus 2 is a quadratic factor. Then the next quadratic factor is going to be x squared plus 1, repeating only once. So its numerator is going to be cx plus d. But then again, since x squared plus 1 is repeating twice, so we'll have to take another partial factor with the denominator x squared plus 1 whole squared. And its numerator is going to be ex plus f. So our goal will be to determine the value of these six constants a, b, c, d, e, and f. We're going to label this as number 1. So what we'll do, we'll take equation number 1 and multiply throughout with x squared plus 2 times x squared plus 1 whole squared. So that means on the left hand side, we are left with only the numerator part. So that's x cubed plus x plus 1. Then we have, since we have to factor out x squared plus 2, so we'll be left with x squared plus 1 whole squared multiplied to ax plus b. Plus we have x squared plus 2 multiplied to x squared plus 1 multiplied to cx plus d. Then we have x squared plus 1 whole squared. So after we factor it out, we have x squared plus 2 multiplied to ex plus f. Okay, so what we'll do, we'll try to expand the right hand side and combine all the like terms. So that is going to leave us with x raised to the power of 5 with a coefficient of a plus c, followed by x raised to the power of 4. So its coefficient is going to be b plus d. Then we have x cubed. So x cubed is going to have a coefficient 2a plus 3c plus e. Then we have x squared having the coefficient 2b plus 3d plus f. And then we have x, the term containing x, with a coefficient a plus 2c plus 2e. And finally, we have the constant term, so that's b plus 2d plus 2f. So here we can observe that there are 6 terms. So let's state all these terms here. So the first term contains x raised to the power of 5. Second term contains x raised to the power of 4. The third term contains x raised to the power of 3. Fourth term contains x squared. Fifth term contains x, and sixth is the constant term. So there are 6 terms on the right hand side. So we'll try to maintain 6 terms on the left hand side as well, although we have only 3 terms. So what we can do, we can rewrite the left hand side as 0 times x raised to the power of 5 plus 0 times x raised to the power of 4. We don't have to worry about the other 3 terms, so that's already present. So we have x cubed plus x. We also don't have x squared. So let's do one thing. So we can rewrite x squared as x squared times 0 plus x plus 1. Now why we wrote in this particular fashion, so that we can compare both sides and we can equate them, such that if we take the coefficient of x raised to the power of 5 on the left hand side, on the right hand side, we have a plus c. We are going to equate it with the coefficient of x raised to the power of 5 on the left hand side. So that will be equals to 0. So this gives us one equation. Let's call it equation number 2. Then we come to the next term, which is x raised to the power of 4. So here the coefficient of x raised to the power of 4, b plus d. And we're going to compare it with the coefficient of x raised to the power of 4 on the left hand side. So that's 0 as well. So this was going to give us the third equation. Then similarly, we have the coefficient of x cubed, so that's 2a plus 3c plus e. So this will be equals to, so here on the left hand side we have x cubed, so its coefficient is going to be 1. So that means on comparison we get the coefficient 2a plus 3c plus e equals to 1. This is going to be the fourth equation. Then we don't have a term containing x square on the left hand side, so that means 2b plus 3d plus f must be equals to 0. This is going to be a fifth equation. Then we have the coefficient of x, so that's a plus 2c plus 2e. We do have an x on the left hand side, whose coefficient is 1. So this equation is going to be equals to 1. This is going to be the sixth equation. And then finally we have the constant term, so that's b plus 2d plus 2f. So this is going to be equals to 1. So this is going to be the seventh equation. So we have 6 unknowns and we have 6 equations starting from equation number 2 till equation number 7. So what you will have to do is you have to solve these equations carefully in order to obtain the value of the 4 constants. So it's going to take, I'll leave as an exercise for you to try out. You have to do it very carefully. So a value will come out to be negative 1. Value of b is going to be equals to positive 1. Value of c is going to be positive 1. D value is going to be negative 1. E value is going to be equals to 0 and f value is going to be equals to 1. So now we have listed out the values of a, b, c, d, e and f. What we'll do, we'll substitute back in equation number 1. Now we will substitute the value. So a is negative 1. So we have negative x plus b. B value is 1. So we have negative x plus 1 divided by x squared plus 2. Then we come to the next partial fraction. So here we have cx plus d. C is positive 1. So we have x and d value is negative 1. So we have x minus 1 divided by x squared plus 1. Then next we have the next partial fraction. Here e value is 0, but f value is positive 1. So we have 1 over x squared plus 1 whole square. So this is how we can convert the given rational fraction, which is x cubed plus x plus 1 divided by x squared plus 2 multiplied to x squared plus 1 whole square into 3 partial fractions. So this is the required partial fractions.